Method of variation of parameters. Now, this method is used to find a particular solution for non-homogeneous equation if the right-hand side is of an unknown form. So remember that for the method of undetermined coefficients, we used to have a particular form of the right-hand side. So if we go back, okay, so these are the forms that we are familiar with, that if you have a polynomial on the right-hand side, or a polynomial times exponential, or an exponential times a sine, or exponential times cosine. So anytime you encounter a form other than these, you have to resort to method of variation of parameters. So now the analogy is very similar to factoring and quadratic formula. You know that factoring is great if it works. The only problem is that factoring doesn't work for every problem. And similarly, the method of undetermined coefficients, which we learned earlier, that is great if you encounter a form that you know on which that can be applied. But anytime you encounter something unknown, then the universal method that you have is the method of variation of parameters. So what we do is we first find two independent solutions, y1 and y2, of the corresponding homogeneous equation. So we start off the same way. We first solve the homogeneous equation and look at the two solutions. And then if y1 and y2 are the two independent solutions, then we set the particular solution equal to v1 y1 plus v2 y2. And then find, in step 2, we find v1 and v2 by solving this system. And finally, once we have found v1 and v2 in this step, we substitute those v1 and v2 in equation number 1, and that gives us the particular solution. So let's see how that works in a practical problem. So find general solution of y double prime plus 4y equals secant 2t. So you see, secant is not something which we know how to work with in the undetermined coefficients. So that's why we now will use method of variation of parameters here. So first we find the homogeneous equation, which is y double prime plus 4y equal to 0. So the auxiliary is r squared plus 4 equal to 0. R squared equals negative 4. That gives r equals plus minus 2i. So these are complex roots, and we know that here the solution will be c1 eat cos bt plus c2 eat sin bt, where a is the real part here, which is 0, because it's like 0 plus minus 2i. So when you substitute 0 for a, e power 0 is 1, so that's gone, and b is 2. So you get c1 cos 2t plus c2 sin 2t. So that's the homogeneous solution. And so the y1 and y2 that we talked about in step A are the two parts of this homogeneous equation. So y1 will be cos t, y2 will be sin cos 2t, y2 would be sin 2t. And it doesn't matter, the order doesn't matter. You can call this one as y2 and this one as y1. It's the same thing. So we take y1 equals cos 2t, y2 equals sin 2t. So remember the two constants that show up, the c1 and the c2, whatever shows up with the c1 is y1, and whatever shows up with c2 is y2 in this method. So once you found the y1 and the y2 through the homogeneous solution, then you set yp equals to v1 y1 plus v2 y2. Remember, that was step B. Actually, it's the second part of step A. And you set yp is equal to v1 y1 plus v2 y2. And y1 is cos 2t, y2 is sin 2t. So once we have found this form of yp, then we need to solve this system. That was step B. We solve this system, y1 v1 prime plus y2 v2 prime equal to 0. And y1 prime v1 prime plus y2 prime v2 prime equals f over a. So y1 and y2 are cos 2t and sin 2t. So that becomes cos 2t v1 prime plus sin 2t v2 prime is equal to 0. And then y1 prime is the derivative of y1. Remember, this cos 2t is y1. The derivative of this is negative 2 sin 2t. So you have negative 2 sin 2t for this y1 prime, v1 prime. And then we have y2 prime, which is the derivative of sine 2t, which would be 2 cos 2t. And then we keep the v2 prime equals f over a. So f is the right-hand side of the given equation, which is secant 2t, and a is the coefficient of y double prime, which is 1. So f over a is secant 2t divided by 1, which is just secant 2t. So now we have to get v1 and v2 out of these two equations. So first we can eliminate one of these. So that can be done if you multiply equation 2 by 2 sine 2t and equation 3 by cos 2t. So you see then this v1 prime term, and then when we add them, the v1 prime terms will go away and you will only be left with v2 prime. So let's do it and see what happens. So multiplying equation, so let's just rewrite these. And what we are saying is we multiply equation 2 by 2 sine 2t. So 2 sine 2t. 2 sine 2t. So every term gets multiplied by 2 sine 2t. And here nothing happens. 0 times anything is 0. So multiply by 2 sine 2t here. Multiply equation 3 by cos 2t. So this one gets multiplied by cos 2t. So let's write the cos 2t here. And when this one gets multiplied by cos 2t, it becomes cos square 2t. What's going on? Okay. Cos 2t times cos 2t becomes cos square 2t. And secant 2t times cos 2t becomes 1. You can do the step. Because cos and secant are reciprocals of each other, so when you multiply these two, you get a 1. So let's say this is 4, this is 5. So adding 4 and 5, we get... So when we add this, you see this is 2 sine 2t cos 2t v1 prime, and this is the same thing but with a negative sign, so these two cancel out. And here this is 2 sine squared 2t v2 prime. So you have this one. Plus you get this one. On the left side. And the right side, when you add these, you get 0 plus cos 2t secant 2t. We can just say that that's equal to 1. And then, or let's just write it as a step To make it more understandable, cos 2t, secant 2t. Let's just write the secant as 1 over cos. Okay, and so now here we can factor out 2v2 prime. v2 prime, 2v2 prime, and then we are left with this one be sine squared 2t plus cos squared 2t. Here. Plus sine squared 2t. Okay, equals to 1. Because cos over cos is 1. And then cos squared plus sine squared is also 1. So we just have 2v2 prime. Remember, sine squared theta plus cos squared theta is equal to 1 no matter what the theta is. So you just get 2v2 prime is equal to 1. So v2 prime is equal to 1 over 2. And remember, v2 prime is dv2 over dt because derivatives are with respect to t in this case. So you can say dv2 over dt is equal to 1 over 2. And now this can be solved by separation of variables v2, so we can take the dt on the other side. So we can bring this 2 on the left. So you can say two dv2 is equal to dt. So when you integrate both sides, you get dv2. The integral of 2 dv2 is just 2v2. 2v2, and the integral of t is dt is just t. So at this point, we don't need to write constants. So you get v2 is equal to t by 2. So okay, so we can substitute this v2 in any of the above equations, and we should go for the simpler one. Substitute in 2. 2 is the simplest. Substituting in 2, we get substituting the value of v2 in equation 2. So that gives us, let's rewrite equation 2. And v2 is t by 2. So V2 is t by 2. So V2 prime will be 1 by 2. Derivative of t by 2 is 1 by 2. And we have to get V1 out of this equation. So we can separate variables by going like this. Is equal to negative 1 by 2. Take this term on the other side. Sine 2t. Okay, so once again, we can use separation of variables. So we write the v1 prime as dv1 over dt. So we have dv1 over dt for the d1 prime, and we have cos 2t. And on the other side, we have negative sine 2t divided by 2 cos 2t. Well, okay, negative sine 2t by 2, that's what we have right now. And now, okay, this is not like that. So in the next step, we separate the variables. So maybe we can bring this is divided by 2, so this comes here with the d1. And we take all of the terms on the right side. So with the dv1, we get the 2 multiplied, and everything else is on the other side. Negative sine 2t is already there, the dt comes over there, and the cos 2t comes down. Negative sine 2t dt divided by cos 2t. Now you can do your u substitution. When you do the u is equal to cosine t, this is the du exactly becomes negative sine 2t dt, so it'd be ln u. So it ends, the integral ends up being ln cosine 2t, but you will also pick up another 1/2 because of this 2 here. So when you do u equals cosine 2t, so on the left side, it's easy. The integral is just, okay, we can do this step, integrating both sides. So the integral of 2 dv1 is just 2v1. 2v1 is equal to, and the integral of this one will be 1 over 2 ln cos 2t in absolute value. And so v1 would be 1 over 4 ln cos 2t. So we have found both v1 and v2, therefore we substitute them in 1. So 1 was where we found the particular solution form, this one. So we can remove this part. Yp is equal to this, and now we have both v1 and v2. v1 was t by 2, or v2 was t by 2, and v1 is 1 over 4 ln cos 2t. So v1 will be replaced with 1 over 4 1 over 4 ln cos 2t, and v2 will be replaced by t by 2. That's what v2 was. Okay, so we have yp, and the question was to find the general solution. So the general solution is yp plus yh. Let's get the template. General solution is y is equal to yh plus yp. Okay, so yh was this one. Plus yp is this one. Okay. C1 cos 2t plus C2 sine 2t. So let's just use A and B. A cos 2t plus B sine 2t plus, what was it, 1 over 4 ln cos 2t cos 2t. 1 over 4 ln cos 2t cos 2t. Cos 2t cos 2t plus t by 2 sine 2t.